Hi everyone, and welcome to another one of our question analysis videos. Today we'll be looking at a spectroscopy question from the 2015 VCAA Chemistry exam. Now this is question number 3, which basically looks at identifying whether a molecule is a carboxylic acid or an ester, and essentially looking at finding its structure. Now let's have a look. We've been given an IR and I've highlighted the keywords or molecular formula, which is very important to help us out. Now I've been told specifically that it's going to be either a carboxylic acid or an ester because it's found in that shelf, and I guess the molecular formula with 2 oxygens in it reflects it. I look at the IR and straight away I notice a C double bond O stretch here, and I notice the absence of a broad merging CH and OH or an OH acid band. So that tells me straight away that this is an ester. Moving on, I can see I've got 3 different hydrogen environments with their splitting patterns provided in the table below, and from the carbon NMR I can see that I've got 4 hydrogen environments. So part A wants us to determine whether the molecule is a carboxylic acid or an ester, and we've already done that, so we said that it's an ester. And because it's 2 marks, guys, I would just go ahead and mention the absence or the lack of that broad merging CH-OH trough to prevent myself from having to write more than I need to. So it's an ester, that would be 1 mark. And the second mark would be my justification or reason, which is the absence of a broad CH broad, we can put in OH acid to save space, OH acid trough between so we've got it, we're expecting it at around 3000, but the range in the data book is between 2500 to 3300 centimeters to the -1. So that would be enough to get us the 2 marks. Now we have to identify for the next question the different number of carbon and hydrogen environments. And when we were looking at, so if we look at the NMR, we can clearly see we've got 1, 2 and 3 hydrogen environments, and in the carbon we've got 4 different hydrogen environments. And so to write that in, it's just going to be 3 hydrogen environments and 4 carbon environments. Moving on, now we have to do the final thing, which is draw the structure of this molecule. Now I can use the splitting patterns from the HNMR to sort of figure out what I have where. And I guess the first thing we have to do, it is an ester, so I would go ahead and just draw in the ester group anyway, and then work around that to make my life a bit easier. We can see, I won't go back and forth, but there was a septet in the molecule, and a singlet and a doublet from the NMR. What we can do with that is we need to sort of think, well, okay, I've got my ester group drawn, and then from here I just have to draw, this is the structure I would go with, and I'll explain why after I draw it. So I've got a carbon that's surrounded, and I'll draw the full structural formula so it's consistent. So I would personally draw it like this and then just have another CH3 coming off at this end, because we can see that if I go back I can get a septet consistent with, I'll get out my highlighter, consistent with this hydrogen environment because it's surrounded by 6 neighboring hydrogen atoms on these 2 methyl groups, and then we can see the methyl groups will split into a doublet, and then the methyl out the you know, over here, and I'll change colors so we don't get mixed up. So the methyl group over here, so the hydrogens here are going to produce a singlet because they're simply not next to any other carbons. And I guess we can see that in terms of, if I was to analyze the carbon environments, I have got 1 carbon environment over here that's not equivalent to anything else. This one's not equivalent to anything else. Neither is this one, but these methyl groups are equivalent because they're attached to the same carbon, so the one that I've put a 3 next to, and both of them are basically next to this single hydrogen over here, so they're attached to the same thing in the same way. I hope this helped you guys. If you have any questions, feel free to get in touch. If you liked the video, give it a thumbs up and subscribe to our channel. We would appreciate it. Thanks.